Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on mesh analysis. For the following network, define three clockwise currents and find their values using mesh analysis. Mark the loops as 1, 2 and 3. Mark the mesh currents as I1, I2 and I3. According to Ohm's law, voltage drop across 2 ohms resistance is given as V2 is equal to 2I1. Voltage drop across 9 ohms resistance is given as Vx is equal to 9I1. Voltage drop across 3 ohms resistance is given as 3I1. Voltage drop across 10 ohms resistance V10A is given as 10 into I2 minus I3. And voltage drop across 10 ohms resistance V10B is given as V10B is equal to 10I3. Apply KVL for loop 1. In loop 1 there are 3 resistors and 2 independent voltage sources. So the direction of current is assumed to be clockwise. So when we consider 2 volt source, as we move from negative to positive, 2 volt source should be taken as positive. When we consider voltage drop across 2 ohms resistance V2, as we move from positive potential to negative potential, V2 should be taken as negative. When we consider voltage drop across 9 ohms resistance V9, as we move from positive potential to negative potential, V9 should be taken as negative. When we consider 1 volt source, as we move from positive potential to negative potential, 1 volt source should be taken as negative. And finally, when we consider voltage drop across 3 ohms resistance V3, as we move from positive potential to negative potential, V3 also should be taken as negative. So we will get plus 2 minus V2 minus V9 minus 1 minus V3 is equal to 0. According to Ohm's law, V2 is equal to 2I1, V9 is equal to 9I1 and V3 is equal to 3I1. So, according to KVL, plus 2 minus 2I1 minus 9I1 minus 1 minus 3I1 is equal to 0. So, solving that equation, we will get I1 is equal to 71.428 milliampere. Voltage drop across 9 ohms resistance V9 is equal to Vx is equal to 9I1. As I1 is equal to 71.428 milliampere, we will get Vx is equal to 642.8571 millivolt. Consider loop 3. By inspection, we can write I3 is equal to minus 0.5 Vx, as Vx is equal to 642.857 millivolt. We will get I3 is equal to minus 0.5 into 642.857 millivolt. So we will get I3 is equal to minus 321.42 milliampere. Apply KVL for loop 2. In loop 2 there are 3 voltage terms, 2 independent voltage sources and voltage drop across the 10 ohms resistance V10A. So as loop current is in the clockwise direction, when we consider 1 volt source, we move from negative potential to positive potential. So 1 volt source should be taken as positive. When we consider V10A voltage drop across 10 ohms resistance, as we move from positive potential to negative potential, V10A must be taken as negative minus V10A. When we consider independent voltage source 5 volt, as we move from negative potential to positive potential, this voltage source should be taken as plus 5. So according to KVL, plus 1 minus V10A plus 5 is equal to 0. 6 minus V10A is equal to 0. V10A is equal to 6 volt. We know that according to Ohm's law, V10A is equal to 10 into I2 minus I3. Therefore, I2 minus I3 is equal to V10A divided by 10. I2 minus I3 is equal to 6 by 10. I2 minus I3 is equal to 600 milliampere. So I2 minus I3 is equal to 600 milliampere and I3 is equal to minus 321.42 milliampere. Therefore, I2 minus I3 is equal to 600 milliampere. Rewriting the terms, we will get I2 is equal to 600 milliampere plus I3. But I3 is equal to minus 321.42 milliampere. Therefore, we will get I2 is equal to 600 milliampere plus minus 321.42 milliampere. So we will get I2 is equal to 278.58 milliampere. So finally, we will get I1 is equal to 71.428 milliampere. I2 is equal to 278.58 milliampere. And I3 is equal to minus 321.42 milliampere. Thanks for watching Circuits Analytica. Enjoy learning.